Okay, so we have another recall. We're going to recall, meaning we've already talked about it, that for a rational function, if the degree of the numerator is 1 greater than the degree of the denominator, then the rational function has a slant asymptote. And what's another word for slant? Oblique. I feel like I have read that sentence and asked that question every day for like 2 weeks. So if we still don't know, that could be a problem. All right. All right, so then we have this graph, and they actually tell us a whole lot of stuff about the graph, but we're just going to talk through it ourselves too. So here's the function in the unfactored form. So if I was going to graph this, the first thing I would do is factor it. So here it is in its factored form. And then I can reduce that, which means I have a hole at x equals 2. And on my graph, I have a hole at x equals 2. All right. Then I would need to write down my reduced version, which would be x times x plus 2 over x plus 1. Then this tells me that I have a vertical asymptote at x equals -1. And that's graphed for me as well. Then I also have 2 zeros at 0 and -2. Those are on my graph. And then whether I look at this version, or this version, I can tell that the function is top heavy. So it doesn't really matter if you figure that out at the beginning or later, it's still top heavy, and it's top heavy by 1 in all 3 forms, which would tell me that I have a slant asymptote. And again, it tells us all of this stuff in here, and it tells us that the slant asymptote is y equals x plus 1. If we didn't know that, we would have to, and by the way, the fact that this is x plus 1 and so is the denominator is a complete coincidence. Okay, don't think that that's where it's coming from. They mean completely different things. But I would have to actually do polynomial long division, right? Because we've already talked about slant asymptotes, we've practiced that, but we also looked at what happens if I don't necessarily need the entire, like for this, I would need the actual line so that I can graph it, right? But one of the things we looked at when we just looked at end behavior was if all I care about is which way it's slanting, so I know if I'm going to infinity or negative infinity, then we were allowed to just take these 2 terms and divide them out, x cubed over x squared. So we ended up with y equals x. And that's knowing that that is not my slant asymptote, but it is parallel to the slant asymptote. And since it has the same slope, it would still tell me about the end behavior either way. Okay, so depending on which route you go, depends on what you need it for. If I need it for end behavior, I can take the easy way out. If I actually need the slant asymptote, I have to do the entire division to get the entire equation. Okay, we okay with that? And I'll kind of repeat that again once we do one. All right, so then this just repeats, same stuff, but maybe if we hear it over and over again. Since the degree of the numerator, which is 3, is 1 greater than the degree of the denominator, which is 2, we knew that it would have a slant asymptote. To find the equation, you use long division. So when we reviewed long division all by itself, I did something very similar to what's on the bottom here. We just divided with pure numbers, used the same steps, did it with polynomials. So I left this on here, but we're just going to skip this because basically we've already done it as a review. Plus we're going to divide some more. So we'll just flip it over. We don't need to do that over and over again. So on example 6, here's h of x. And it says use long division to find an equation for the slant asymptote. Oh, I did want to point one other thing out. Sorry, you don't necessarily have to flip it back over. But I wanted you to see that we had this version. We factored it so we could reduce to get that. But then if I was going to actually do the long division, I can't do the long division from this form. I would have to multiply it back together and get x squared plus 2x over x plus 1. And then I could do the long division, okay? And I could have done the long division here as well, but don't you think this one would be a little bit easier if we had to actually do it? So it's kind of better to wait. All right, sorry, just realized I forgot about that. All right, so we have this. I mean, I could factor it and try and reduce it, but if I don't have to factor something that has that 6 in the beginning, I'm not going to, and I don't have to. And it does say use long division to find the equation. I highly doubt if you were actually asked for that, it would say use long division. It would just say find the slant asymptote, and then you have to know to do that. So we're going to have 2x plus 1. We're going to divide it into 6x squared plus x plus 5. Remember to pay attention to any missing terms so you can have a placeholder if you need to. There's none here, but that is important. All right, so then 6x squared divided by 2x leaves me with what? 3x, so I put that above my x. When I multiply it back, 3x times 2x is 6x squared. If what you get doesn't match what was there, you did something wrong, because that's the whole reason that's how you got it. Then 3x times 1 is a positive 3x. This next step is super important. What is it? Change the signs on the bottom row. So then these zero out. This leaves me with a negative 2x, and I can bring down my 5. Then I have negative 2x divided by 2x gives me what? Negative 1. Do I need to go any farther? I do not. Because I know I'm going to get a remainder. I should get a remainder. Do I care what it is? No. So once you have your equation of your line, you're done. And the equation for the slant asymptote is y equals 3x minus 1. It's a line, so make sure you write it as an equation of a line. Everybody good with that? All right. So let's look at example 7. It says find the equations for any asymptotes. Oh, I also wanted to say this because somebody said something earlier and I was like, oh, you had Mrs. Archer last year. Let's just look at this word real quick. That's asymptotes, not asymptotes. Somebody said asymptote, and I was like, you had Archer. So if any of you had Archer, we love her. I make fun of her to her face about it, but it's asymptote, not asymptote, because I don't want anybody to make fun of you. We can make fun of her. She's my friend. I make fun of her to her face. It's fine. Asymptotes. So we need the factored form is what it says, but I don't have to factor it just yet. I can already answer some of this. Is this top heavy, bottom heavy, or tied in degree? Top heavy. So tell me what that means for horizontal asymptote. None, okay? And would I have a slant asymptote? Yes, because it's just one greater. And remember with these two, you'll have one, but you can't have both. And you will have one or the other, because we're not going to get the parabolic asymptotes or anything else weird. So for us, we're going to have one or the other. All right, but in order for me to figure that out, again, I could do my long division here, but maybe I can cancel something out first. So let's try that. So I don't really have a whole lot of room for where it says factored form, so let's do it right here. G of x is equal to, all right, in the numerator, I can factor out an x, leaves me with x squared plus 4x minus 12. So that gives me x times x plus 6 times x minus 2. Then the denominator would be x plus 1 times x plus 6. And I'm going to remind you again, you have to be able to factor accurately and efficiently, which means kind of quickly, especially on easy ones like this. You can't spend 10 minutes trying to factor it because that's like not even really part of what's being tested. So then I look at this and decide, can I reduce it? Can I cancel anything out? Yes, I can cancel out the x plus 6. So that tells me I have a whole at x equals negative 6. And I realize that this question didn't ask that, but I don't ever want to just ignore something like that where you think you just cancel it out and it just like poof disappears and doesn't mean anything. So then my reduced version looks like this. So x times x minus 2 over x plus 1. All right, so the other thing, I have my factored form, vertical asymptotes. Do I have any? At x equals what? Negative 1. Good. Now to find the slant asymptote, I'm going to have to divide. But before I can divide, I have to multiply it back together. So g of x is equal to x squared minus 2x over x plus 1. So then here, I'm going to take x plus 1 and I'm going to divide it into x squared minus 2x plus 0, because you need a placeholder even for the constant term. Otherwise, we make mistakes that we don't want to make. All right, so x squared divided by x gives me x, so I put it above the x term. Multiply it back, I get x squared plus x. Then I change the sign on the second row. Those zero out, so that's negative 3x plus 0. So having the 0 here isn't necessarily why it was so important. It's that if I didn't put this here, my division symbol or my division sign, my little house would stop right here. And then I might think I'm done, and I'm not. I have to put something else there, right? So negative 3x divided by x gives me a negative 3. Then I can stop. And I've got x minus 3. Again, if all I cared about was what's the end behavior here, then I could take these two terms and take x cubed over x squared, and I would get y equals x. Not the equation of the slant asymptote, but it would have the same slope, which would tell me about my end behavior. Okay? We good with that? What questions you got? All right. Example 8 is kind of similar to that one we worked at the beginning. So I have this function, and it says, which of the following about the graph is correct? Now, from all the College Board stuff I've seen for AP Pre-Cal, I haven't yet seen any questions where they say, which one is not correct, or which one is not the answer. Don't y'all hate questions like that? Yes. Oh, it's right here. I put the arrow right, this is the factored form. I just couldn't really fit it there, so like basically this is it. Yeah. I should have spaced it down some. But now this doesn't mean that they couldn't put one on there, but I haven't seen it, but still read stuff carefully. We're looking for which one is correct. Now if I just kind of scan my answers, I can see for the first half of it, it's like horizontal asymptote or slant asymptote. So I'm going to look just at that part first. Is this function top heavy, bottom heavy, or tied in degree? Top heavy. Okay, so which one can I eliminate? A and B, right? Because they both talk about horizontal asymptotes. So now I got a 50-50 shot if I had to guess, but you know, we don't want to have to bank on that. So they were nice enough to factor the numerator for me. I need to factor the denominator. Okay. And this would give me x minus 1 and x minus 1, which I could make x minus 1 squared, but I'm about to reduce it, so I don't need to. And just to kind of answer your question again, this would be the factored form, like before I even cross anything out. Now, if I start, it's okay to cross it out in your factored form. You have to rewrite it. But I can reduce here. So that means it looks like I have a hole at x equals 1. Then I have this left. Looks like I have a vertical asymptote at x equals 1. Can I have both? No. Which one wins? Vertical asymptote. So that goes away. I have no holes and one vertical asymptote. My answer is D. Even on these, do it a piece at a time. Don't worry about the whole thing all at once. You can eliminate some things as you go. Okay? What questions you got? All right, so on example 9, we're going to sketch a picture. I'm going to remind you again, on the AP exam, nobody's going to make you graph one. I'm going to have you graph one on your assignment, and I want you to try it and not freak out, okay? You can do this. And really more than anything, if you can stay with me through the thought process of how I graph it, that's really more important than you being able to graph it. Because I know that because you haven't really graphed a ton of these before, or at least the weird looking ones, you're kind of unsure what to do, but you're really not unsure. You think you're unsure is part of it. Because what this question would really look like is you'd be given maybe these same 4 statements and then 4 graphs and you have to match them up, okay? But if we can, you know, sometimes do it from scratch, then we understand it a little better. All right, so let's look at these first 2 limits. I have the limit as x approaches infinity is negative infinity. So that means as x gets bigger and bigger and bigger, y is getting smaller and smaller and smaller. And as x goes to negative infinity, y is going to infinity. So based on those two statements, do you think this function has a horizontal asymptote? No. Good. Good answer. Let me show you what it would look like if it did. So if I had a horizontal asymptote, let's say that's it too. Why not? We're just making this up. And it maybe looks like this. Then what my limit would look like, it would be the limit as x approaches infinity. So as x is getting bigger and bigger and bigger of f of x, y is approaching the asymptote, which is at 2. So if I have a horizontal asymptote, my end behavior when I approach the infinities, I'm approaching the asymptote, so my answer to those limits would be a number, right? And I have an infinite amount of things it could be. Since my only options are horizontal and slant asymptote, if x is going to infinity and y is going to a negative infinity, that's what the right-hand side looks like. When x goes to negative infinity, y goes to infinity, that's what the left side looks like. And I know this thing has to be a line because we're not getting crazy. Then I have a slant asymptote that looks like this. Now, do I know the actual equation from this? No, they haven't given me enough information. But I do know that it has a negative slope. That's really all I know, but that's something I know. Do you see how I figured that out instead of it being horizontal? Okay, so that's something. Then I look over here. The limit as x approaches -1 from the left. So I'm just going to do another little sketch for myself here. Here's -1. As x approaches -1 from the left, y is approaching negative infinity. And as x approaches -1 from the right, y approaches negative infinity. So what has to happen at -1 for that to happen? Vertical asymptote, exactly. I have to have a vertical asymptote. Because in the middle of a graph, when it's approaching negative infinity or something, you're hitting an asymptote. Well, you don't actually hit the asymptote, but you're coming up on one, so you're going down like that. We good on that? So that tells me on here, I have a vertical asymptote at -1. These limits don't tell me anything about my zero, my y-intercepts, but that's okay. I know that my graph has to be approaching negative infinity on either side of that asymptote. The other thing I know is that I have a slant asymptote that looks something like that. Now, because again, I don't know exactly what my slope is or my y-intercept. All I know is that it has a negative slope. We don't have to be crazy and creative. We can just make it simple and maybe say, okay. Because remember, this is a graph that has these. It's not like the only graph it could be. But my slant asymptote could look like that. You with me on that? Then knowing what we know about asymptotes, we can finish out the rest. And even though we are allowed to cross horizontal and slant asymptotes, when you are sketching a picture, it might be best for you just to not do it so that you don't make anything complicated. Because if these are asymptotes and I pretend like I can't touch them, then this is the only thing that could happen, and this is the only thing that could happen over here. Because remember, the only place that your function is not defined is at a vertical asymptote or a hole, and we had no information about holes up here. Okay, what questions do you have? That wasn't that bad, right? I think getting to this part y'all are usually okay with. It's filling in the rest. You're like, how am I supposed to know that? And that, again, you do know because you know what happens with asymptotes. It just takes you some, I don't know, some bravery maybe to actually sketch something in. But that's why I just want you to try, okay? What questions do we have? Anything? We good? All right. So